square root on like a homework assignment, I'm going to be checking that you have the correct transformations, right, left, up, down, stretch, shrink, reflect, whatever those are, that you have the right shape, if it's a square root or a cube root graph, and that you can do domain and range. But I'm not checking a table of values, so your graphs could be sketches. The parent graph, because we don't know what the graphs look like right now, we need a table of values. So we need to pick some x's to put in our table of values. What x's would you like to see in the table of values? What's that? Any x's? 8. What else? 2. Oh, 1, 2, 3, -1, -2, -3. What other number there did you just skip over? 0. I mean, I like Eric's suggestion. I mean, and Jackson's like, why are you asking us? We can pick anything. You know, I like Eric's suggestion only because he has all different kinds of numbers, right? He has some positive numbers, he has some negative numbers, and then we're also going to see if 0 works. Okay. So I'm actually going to start at -1, if that's okay. What happens if x is -1 and you try to do the square root of -1? It doesn't work. It would be an imaginary answer. In fact, the square root of -1 is I. Will we be able to graph I? Not on this real coordinate plane. So when you put -1 in, you don't get a y back out. So that's why I'm not going to put in -2 and -3, because we're going to have the same scenario, right? Will any negative number work? Not for a square root, because we can't take square roots of negative numbers. But we should check 0. If x is equal to 0, can you do the square root of 0? 0. We could check +1. Square root of 1 is 1. And then Eric's suggestion was 2, 3. Jackson said we could pick really any x, like we could even go all the way up to 8. I'm going to put 4 right there. So we could do 1, 2, 3, 4. And which of any of those 2, 3, or 4 would you most like to evaluate right now? 4, because you can do the square root of 4 in your head. What is the square root of 4? 2. Okay. So these are valid numbers, x equals 2 and x equals 3, to put in the table. And I'll come back to these as decimals. If you have a calculator, it's like no big deal. Okay. But if I didn't have a calculator, I wouldn't choose those two numbers because I don't know what they are right now. I could guess, I could estimate, but I'm going to go ahead and just use 4. What's another good x I could put in then? 9 would be the next best number, right? Because the square root of 9 is 3. So if you were going to go and take the route of doing a table of values, I would recommend choosing your values of x wisely so that you actually can take the root of them. Like we're going to choose 1, we're going to choose 4, we're going to choose 9, because we know the square roots of those numbers. Could you please graph the ordered pairs that we have? So like 0, 0, 1, 1, 4, 2, 9, 3. Let's get those points on the graph. Will those 4 points be connected by a straight line? No. So the square root graph is kind of curved. All square root graphs have this shape. It doesn't have a special name, like the quadratic is a parabola, or we can easily say the absolute value is a v. I have always sort of described the square root graph as a little hill. A hill that is increasing. It doesn't turn around, it never starts to decrease, right? It doesn't turn like a parabola. But it just kind of is this little hill I could drive up. Don't draw this on your notes, but just to give you another connection to what the shape looks like. The square root function is really half of a sideways parabola. Yeah. We don't include the other side because then it wouldn't be a function. It wouldn't pass the vertical line test. But to give you some reference as to like how you're going to draw the shape that is the square root graph, think about it like one of the arms of a sideways parabola. Okay. So that's not actually part of the graph. Okay, the only other things we want to add to this is I want to talk about domain and range. Does anybody remember anything about domain and range? Damon, what do you think you might remember? A lot of times, yes. When we did domain for absolute values and quadratics, it was all real numbers. Because we could take the absolute value of anything and we could square anything we wanted to. There are no rules to what we can or cannot do. Are there rules to square roots? Are there some numbers you can't take square roots of? So we won't have a domain of all real numbers anymore. What kind of numbers do we have to have? Positives and... there's one number up there that's not positive or negative. 0. Okay. So when you're talking about domain, you're talking about all the x's that work. You can plug these x's in and you'll get answers back out for y. And so like if you're testing in the left side of your graph, -3 doesn't work because there's no graph over there. -2 doesn't work, there's no graph. -1 doesn't work, there's no graph. The first point that works is 0. So it's x's that are greater than or equal to 0. And that the greater than has Eric's positive, and then the or equals to has the fact that 0 can be square rooted. What about range? What kind of y's do you get out in the parent graph? You get what? More positives, right? They're all above the y or the x-axis, so they're all positive. What's the lowest y you can have? 0. At 0, 0, there's a point, correct? So this start point, the x is for domain and the y is for range. So here we'd say y is greater than or equal to 0. So that's really interesting. I'm glad you remembered that, Damon. Previously, we have worked with functions that always had all real numbers for domain. The square root is the first graph or first function family we've encountered where that's not true. We'll always have some kind of restriction because you can't take square roots of negative numbers. It's a rule. Does anybody have any questions about the parent graph for the square root that I could answer? Okay, let's do the parent graph for the cube root. Over on the right side, what kinds of numbers you want to put in for your x's here? Eights. Why'd you choose 8? Because you could do the cube root of 8. Okay? That's a great idea. I'm going to put 8 in my 5th box down. Only because, you know, I like everything to always be in order. So I'm going to put 8 right there. What other number might you put in? 0 would be a good one. That's going to be easy. I guess we could do these. The cube root of 0 is 0. The cube root of 8 is 2. What's another good number? 1. The cube root of 1 is? 1. You should always put 1 in. -1. You could put 27 in and you'd get 3. But Jake said -1. What's the cube root of -1? -1, because -1 times -1 is 1. And then 1 times -1 is -1. So -1 multiplies by itself 3 times to be -1. You can do odd roots of negative numbers. We've talked about this back in the early sections. So another number you might put in there is -8. Because what's the cube root of -8? -2. -2 times -2 is 4. 4 times -2 is now -8. So -2 multiplies by itself 3 times to give us -8.
So because this is a cube graph, do you think that we should scale it?
No. So like Sierra had mentioned 27. And I'm probably just like, not going to put that one on my graph. But on this, I think you have enough space. Like, can you go 8 to the left? I think you can. And then you'll go 2 down. So you'd have a point right there. I don't think you have to scale it. If you wanted to put 27 on there, then yeah, you probably have to scale it. But I'm just going to leave that point off. And then I'll do -1, -1, 0, 0, 1, 1, and then I'll do the 8, 2. Now this is a really interesting graph, and this one can sometimes be challenging for us to make the shape correctly. I will tell you, I'll take off if your graphs don't look like the right shapes. And so sometimes part of what you have to do in this section is just like learn how to draw these funny curves, okay, and make sure that you're drawing them correctly. This one's kind of like a square root on the right side. And then on the left side, it's sort of another one of those curves, but it goes down towards the left. When I look at the cube root as a whole, I think it looks like a stretched out S. Like if you had drawn S and then you pulled it, that's what that kind of reminds me of. There's like this special bend in the middle where it sort of changes the way it curves. Okay. And that's an important part of like the actual shape of the graph. So that's something that you want to practice to make sure you're drawing correctly. Let's talk about domain and range for this one. What do you think about domain and range here? Are there rules about cube roots like there are for square roots? Can't take square roots of negative numbers? Does the cube root have a rule like that? No. So the domain should be? What was it when we didn't have rules back in chapter 1 and chapter 2? All real numbers. Sure. And do you remember when I would draw that fancy R? It had 2 sides. I'll draw it like this. X equals, and then I draw 2 sides and an R. You remember that? Okay. That says to me all real numbers. If you would rather write out the 3 words, all real numbers, you could do that. Okay. I'm too lazy to do that. But yeah, when there's not a rule saying that you can't cube root something, then you're going to have all real numbers for your domain. Okay. What about range? Is there like a highest point or a lowest point to this graph? I don't think so. Like this side on the right is really going up forever. It takes a while for it to get up, right? But it's always going up. And this side is always going down. So if one side's going up and I'm connected and then the other side's going down, I'm eventually going to hit everything, right? All the numbers. So the range for a cube root is always all real numbers. I loved cube root graphs, domain and range, because it's the easiest. All real numbers, all the time. Never have to worry about it. Square root, you have to worry about domain and you have to worry about range every single time. Okay. Are we okay with this? Okay, so I would like you really quickly to have a conversation with the people around you. In the middle of the page there, what do A, H, and K do to your graphs? So talk to your shoulder buddies, or if you want to form small groups with your shoulder buddies. Okay, what do A, H, and K do? Cool. What do A, H, and K do? Don't be shy. Skylar, what'd you guys say? She's smiling.
Does the A like move it up and down, or does that one move it side to side?
Good question. Damon?
A like stretching.
Oh, yeah, do stretches.
A is responsible for stretch and shrinks. And I'm going to say, you know that it's being stretched if the absolute value of A is greater than 1. Like if there's a number in front of the function that's like 2, 3, 4, 5, it gets stretched. So our graphs are going to look taller when we stretch them. And then it will shrink if the absolute value is between 0 and 1. So if you have like fractions in front of your function and you're multiplying by 1/2, then it gets like shorter. When our graphs shrink, we're still going to have that like curvy shape to them, but shrinking our curves will make them look more like lines. Like the curves will be less, and then when it's shrink, and the curves will be like more when it's stretched. Okay. Let me say this about stretch and shrink. Because I'm not requiring you for your graphs to actually do a table of values, stretch and shrink is something I grade when you tell me about the transformations, but I don't really grade your stretch or shrink on the graph because it's hard for me to tell if your square root has been stretched unless I see your original square root function. Okay, so worry more about stretch and shrink in terms of telling me it happened, okay, rather than when you put it on the graph. What else? A, H, or K? I heard good thoughts as I went around the room. Faith? Yeah, H moves it left and right. And do you guys remember how we always talked about H? H is like the opposite of what you think. So when it looks like X minus H, it goes to the right. When it looks like X plus H, it goes to the left. And it's like opposite of what we would intuitively think. And you'll always know the number that's H if it's underneath the radical. So when you look up here, you have to pay careful attention to like where the radical ends. Okay? Numbers that are underneath the radical with X are H's, and numbers that are outside are K. So can you tell us what K does? Yeah, it goes up and down. And K looks like what you think it should. Like plus K is up and minus K's are down. There's one other transformation that we don't have up there. Okay? Yeah, if there's a negative at the very front, it's going to flip your graph. Which one of the letters would be negative? A. So I'd add here, we're going to say reflect in the x-axis, or flip it when A is negative. So instead of having like the little hill that goes up, it would flip over the x-axis and it'd kind of be like a hole going down. Okay. And then instead of like the S, the stretched out S shape increasing from left to right, if you flipped it over the x-axis, it would be decreasing from left to right. Okay, so it's just a reflection in the x-axis. Very good. Let's look at some examples, the two examples at the bottom of the screen. Okay, here's what I want you to do on your homework assignment. Okay, I want you to tell me the transformation. So give me words. Left, right, up, down, stretch, shrink, reflect. What happens to y equals the square root of x minus 5 plus 1? Riley, can you put your phone away? Thanks. Goes up 1. What else? We took care of the 1. Jacob?
It goes 5, right?
Goes right 5. And the only other thing I really consider, I think about this in my head, so this is my thought bubble. Which shape is it going to be? Is it going to be the square root shape or the cube root shape? It's going to be the square root shape. So I'm going to start at 0, 0 and go up, but now I'm shifting all of that. Okay. So I'm going to take this start point and I'm going to move it right 5 and up 1. So I'm going to go right 5, up 1. That's the new start point. There was no reflection, no stretch, no shrink. That's my square root. I'm not requiring you to graph any other points. If you want to graph some more points, you can make a table of values. Okay, but you just have to have the right shape in the right location. Are we okay with how I drew my graph? Let's talk domain and range. Remember, for square roots, there's a restriction to both. What's the first x that works for domain? Does 0 work anymore? Does 1? 2? 3? 4? 5? 5 works? So x is greater than or equal to 5. Range would be y is greater than or equal to 1. Do those numbers 5 and 1 sound familiar? Not a problem? Yeah, they're the right-left movements and the up-down movements. So the numbers that are h and k in square roots are also included in your domain and range, because that's the new start point. Instead of 0, 0, it now starts at 5, 1. So 5 goes with domain, 1 goes with the range. Okay. What are the transformations for y equals the cube root of x minus 1 minus 3? Give me one transformation, Cole. Words like left, right, up, down, stretch, shrink, reflect.
Left 1.
Left 1. Down 3. Damon, you still have your hand up.
Would it be right 1?
Would it be right 1? Look at your notes. In transformations, if it looks like x minus h, what direction does it go? To the right. It should be right 1. Right 1, down 3. Got a graph? What shape is it going to be? Square root, cube root. Cube root, which is that S shape. So this is the place, this point right here that I've graphed, that's the bend. So that's where it changes. This side curves up, left side curves down. So the point that I moved is the bend of the graph. Domain and range? Super easy. Always what? All real numbers. All the time for cube roots. Cube roots have no restrictions either way, based on the shape of their graph and the function that they are. On your homework assignment, first 4 questions are graphing questions. I want you to, in words, state the transformations. Draw a sketch of the graph. You do not need a table of value. I'm checking for correct shape in the right location. Do domain and range. Okay. Here is your homework assignment.